Every time you stop at a gas station, gasoline feels almost too ordinary. You pull the handle, watch the money and liters climb, and a few minutes later, the car is ready to move again. Yet that liquid did not simply appear beneath the pump. Before it reached your tank, it was locked inside ancient rock, mapped with sound waves, pulled through steel pipes, heated until much of it became vapor, separated inside a refinery tower, tested for how it behaves in engines, and carried in trucks where static electricity has to be controlled. Gasoline looks simple because we meet it after the hard parts are over. So how is it actually made? To understand that, we have to go back to what it starts as. Let's get into it right here on Secrets of Simple Things. Gasoline does not start as gasoline. Gasoline begins as crude oil, a thick, natural liquid formed from ancient organic matter buried under heat and pressure for millions of years. Crude oil is not rough gasoline. It is a dense blend of different molecules, each useful in a different way. The molecules most useful for gasoline are lightweight hydrocarbons, built mostly from carbon and hydrogen atoms. When they burn inside an engine, they release energy quickly enough to push pistons, turn wheels, and keep vehicles moving. A barrel of crude oil is not reserved for one fuel. Inside it are fractions that can become diesel, jet fuel, kerosene, lubricating oil, asphalt, and materials used to make plastics. Some parts move cars, some help pave roads, some end up inside objects that do not look connected to oil at all. In that sense, crude oil is less like one ingredient and more like a mixed box of modern life. The strange part is that none of those products are visible at first. They are hidden inside the same dark liquid. Before anyone can separate that box, they have to solve a harder problem. Where is the oil in the first place? Oil is not an underground lake. One of the easiest mistakes to imagine is that oil sits underground like a dark lake, waiting for someone to drill a hole and drain it. The truth is less obvious. Crude oil is usually trapped inside tiny spaces in porous rock, sealed beneath layers of sediment, stone, and time. Finding it begins long before a drill appears. Geologists study ancient rock formations, buried folds, fault lines, and sediment layers, looking for shapes that might have held hydrocarbons for millions of years. A single clue is not enough. They are searching for a whole underground pattern. Then comes seismic surveying. Powerful sound waves are sent into the ground. As they hit different layers of rock, they bounce back in different ways. Sensors collect those echoes and turn them into underground maps. It is almost like giving the Earth an MRI scan, not to see bones or organs but hidden structures miles below our feet. Even with advanced maps, no one can know for sure until a well is drilled. Oil exploration is not blind guessing, but it is not certainty either. It is a calculated bet. When that hidden map finally shows promise, the most demanding part begins: drilling down. Drilling is not digging, it is controlled pressure. Drilling for oil is not like digging a deeper version of a water well. The drill bit has to grind through sandstone, shale, granite, and other rock that has been compressed for ages. It moves section by section, while long pieces of pipe are added one after another, turning the drill string into a metal spine reaching deep into the earth. The hole itself cannot be left open. As the well gets deeper, steel casing is lowered into place and cemented against the surrounding rock. This keeps the walls from collapsing and prevents different underground zones from mixing. At the same time, drilling mud is constantly pumped through the well. It cools and lubricates the bit, carries crushed rock back to the surface, and helps control pressure. It is not just a support fluid. It is part of what keeps the whole operation calm. Deep underground, The Earth is not passive. Oil, gas, and other fluids can be trapped under enormous force. If that pressure escapes suddenly, it can cause a blowout, an uncontrolled surge toward the surface that can lead to fire, explosion, and severe environmental damage. The real challenge is not only reaching the oil, it is reaching it without letting the underground pressure fight back. If the well passes that pressure test, crude oil can finally begin to rise from rock that has held it for millions of years. Bringing crude oil to the surface. Once the drill reaches its target depth, the well is not opened immediately. Engineers measure pressure and temperature, collect fluid samples, and look for proof that hydrocarbons are present in useful amounts. Only then does exploration become production. At first, the oil may rise on its own. Natural pressure can push crude through the production pipe toward the surface. When that pressure weakens, pump jacks take over, those slow, rocking machines that look almost sleepy from a distance. In reality, they work like giant metal syringes, pulling liquid up from rock far below. The oil is finally moving, but it is still carrying pieces of the underground world with it. The crude travels through pipelines to separation vessels, where gases that came up with it are removed, including natural gas, carbon dioxide, and hydrogen sulfide. What remains is still raw, dark, and messy, but now it can travel. The oil has been found, reached, and lifted. The next question is what can be separated from it. A refinery does not make one product, it separates a whole world. A refinery is where crude oil stops being one dark liquid and starts becoming many useful things. Before the main separation begins, some unwanted compounds have to be handled first. One of them is hydrogen sulfide, a toxic gas that can be removed and converted into sulfur, which can later be used in products like fertilizer. Then the crude enters the heart of the refinery, the distillation tower. The oil is heated to more than 700 degrees Fahrenheit until much of it becomes vapor. That hot vapor is sent into the lower part of a tall column, and as it rises, it cools. This is where the sorting happens. Different molecules in crude oil have different boiling points. The heavier ones cool and condense sooner, so they settle lower in the tower. These can become asphalt or heavy fuel oil. Higher up, slightly lighter molecules condense into diesel. Above that, other fractions become jet fuel and kerosene. Near the top, where the temperature is lower, lighter hydrocarbons are collected as gasoline. The tower works because crude oil is not one substance behaving one way. It is a packed mixture, and heat gives each part a chance to separate from the others. A refinery is not turning one liquid into one product. It is sorting the fuels and materials hidden inside it. That is why a single barrel of crude can lead to fuel for cars, planes, roads, machines, and plastics. Even after the gasoline fraction has been separated, it still cannot go straight to the pump. Gasoline has to behave inside an engine. After separation, gasoline has to prove that it can behave inside an engine. Refineries test each batch for its octane rating, the number drivers see at the pump. Octane is often misunderstood. It is not simply a measure of how powerful gasoline is. It measures how well the fuel resists knocking. Inside an engine, gasoline is supposed to ignite at a precise moment, in rhythm with the piston's movement. Think of the engine like a small orchestra. Every spark, explosion, and movement has to arrive on time. Knocking happens when the fuel ignites too early inside the cylinder. Instead of one smooth push, the engine gets a sharp, uneven hit. Over time, that can reduce performance and damage parts. Gasoline does not just need to burn, it needs to burn at the right moment. If a batch fails the test, it is adjusted before distribution. Only when it meets the required standard can it leave the refinery. Once that happens, the journey changes from chemistry to logistics. The last trip is still dangerous. After testing, gasoline moves through pipelines to loading terminals, where tanker trucks take over. This part looks routine from the outside. A truck, a hose, a tank, a driver checking equipment. The risk is in what we do not see. Gasoline vapor is highly flammable, so loading has to be controlled carefully. The danger can start with something invisible: static electricity. As fuel moves quickly through pipes and into the metal tank, electrical charge can build up on the truck. Near gasoline vapor, even a small spark is enough to become a serious hazard. That is why tanker trucks are grounded before loading. The grounding cable gives static electricity a safe path away from the fuel. Other safeguards handle different problems. Overflow sensors stop the flow when the tank reaches capacity. Vapor recovery lines capture fumes instead of letting them escape freely into the air. The goal is not drama. It is prevention. When the truck arrives at a gas station, its hose connects to underground storage tanks. Valves open, and gravity carries the gasoline down below the forecourt. There it waits beneath a pump, ready for the part of the story we actually see. The pump is only the final scene. So the next time gasoline flows into your tank, it may look like the simplest part of driving, but by then, the real journey is already over. The oil has been found in rock, lifted through pressure, broken into fractions by heat, tested for engine timing, and moved through systems designed to keep sparks, fumes, and overflow under control. That is the quiet trick of ordinary things. By the time they reach us, the complicated parts have usually been hidden underground, sealed in pipes, or finished miles away. We only see the clean final action: pull the handle, fill the tank, drive away. The pump is only the final scene. The real story started long before you arrived at the gas station. Subscribe for more simple things with hidden stories. And if this made you see gasoline a little different, leave a like, share this video with someone who drives every day, and subscribe to Secrets of Simple Things for more simple things with hidden stories. Because the most ordinary objects around us usually have the longest journeys behind them.